This section is actually optional. College Board will not test it, but I find it fascinating. Calculus is used behind the scenes in a lot of our technology, including our graphing calculators. You ever wonder how calculators can figure out things like e or pi or random square roots or cube roots of numbers? I mean, programmers can't anticipate anything and everything that somebody might type in, so there is a method. And this method was made by Sir Isaac Newton, of all people. And he figured it out before calculators were even invented, which I think is even more impressive. This is his method, as I said in my own words. And you can see that I've used the word guess a couple times. Our graphing calculators, Texas Instruments, that we use actually say guess sometimes when you're trying to find things. I always thought that was kind of cool. Those calculators are using Newton's method behind the scenes. Textbooks don't like to use the word guess. Typically, they'll call it an iteration, because iteration just sounds smarter. It means the same thing. It means a guess. All right, so you're going to start with a random guess. So if we're trying to figure out pi, maybe our initial guess would be 3 or 3.14. And then the new guess takes that old guess, the 3, and you subtract the original function divided by the derivative, and that gives you a new improved guess, or a new and improved iteration. And you keep doing this over and over until you get an answer that's pretty accurate. Here's the more formal way to write Newton's method. This x with the subscript n plus 1 is the n plus first iteration. What you do is you take your initial guess, or the nth guess, and to get the n plus 1th, you simply subtract that same fraction I mentioned, the original up top, derivative on the bottom. Again, the best way to do this is just to simply show you how. So let's do some examples. How on earth does a calculator know what the fourth root of 93 is? I mean, certainly nobody who programs a calculator could anticipate that somebody would type that in. Or what if I typed in 93.1 or 93.065? You can't anticipate everything. So here's what the programmers do. You're going to form an equation where this is the answer. I think that could be the toughest part for newbies. Here's a good example. X to the fourth minus 93 equals 0. If you put the fourth root of 93 in, you can see that that will work. Okay, so step one is to form an equation where this thing that you're trying to figure out is a solution. All right, so I've done that. Now what Isaac Newton did is he changed the 0 to a y. How come Isaac Newton did that? Well, I have to be honest with you, I'm not him. Not nearly as smart, not nearly as famous. I don't know if I'll be around in another 200-300 years like he is. Maybe these videos will be, who knows. But that's the genius of Isaac Newton. He decided to make that into a y. And then, since he was dabbling in calculus, he took the derivative, which again was something that he was discovering, and then he turned it into a fraction, like so. We're going to use this fraction to our advantage. And again, he did this without calculators, which I just find amazing. Now, since I have a calculator, I'm going to shamelessly cheat and just type in the fourth root of 93. I'll go 93 to the 1/4 power, 0.25 power. Here's what the answer should be. I can only imagine what Isaac Newton would say if he saw this powerful technology back in his day. He'd probably be like, what? So I'm going to make my initial guess 3. All right, so we'll say 3 is the initial iteration here. So what I want to do is I want to start with the 3 on the calculator, and I want to go 3 minus the fraction. And I'm going to plug these guys in, and the answer should get better and better and better until eventually we arrive at this 3.105, 422.799. Okay, here goes. Let's start with the initial guess or iteration. We'll type a 3 in, and this is important. You have to hit enter So the 3 goes to the right-hand side of the screen. Then we go minus, and we make the fraction. But rather than saying x to the 4th minus 93, I'm going to say answer to the 4th minus 93. So second answer, it's behind the negative key. Answer to the 4th minus 93, make sure I put parentheses around that, divided by 4 answer cubed. Whoops, so let's not do that. Let's get rid of that. Come down. Full-size parentheses. Okay, that looks great. Because that way they'll take the 3 and plug it in. But if we do it again, we don't have to keep retyping it. And you can see that just after 3 iterations, we're already to the answer that we had already. I just keep hitting enter until the decimal no longer changes. And that was the exact answer that we had when we typed in the 4 through to 93 directly. So calculators work behind the scenes by using Isaac Newton's method. The new guess is the old guess minus original divided by derivative. Let's try another one. Okay, here's number 2. In Algebra 2, which is probably when you first started doing this, you had some graph like this. That's going to be a parabola, 3x squared minus 4x minus 5, opening upwardly. It's going to maybe cross the x-axis, possibly twice, maybe only once if it bounces off of it. And we're saying, hey, it's going to have a positive root or a positive solution. Find it. And normally you get on there and you'd be like second calc, root, or 0. And it would say left bound, right bound, guess. And the guess is actually Newton's method. We're going to use Newton's method right now. You actually don't have to come up with an equation this time because it's there already for you. But you are going to pull in Isaac Newton. You're going to change the 0 to a y. Because if you were Isaac Newton, that's what you would do. All right, so y equals that. Y prime, the derivative, is going to be 6x minus 4. And that's all there is to it. Let's go ahead and jump onto the calculator. We'll just go from there. So I'm going to type in the original equation, y equals 3x squared minus 4x minus 5. Okay, there it is. Let's go ahead and graph it. All right, it is a parabola. It does cross the x-axis twice. We want the positive root. It looks like it's going to be 2 point something. All right, I'm going to make my initial guess 2, but I'm not going to use the old-fashioned way. I'm going to use Newton's method, which is actually better. So our initial guess is going to be 2. We go minus, notice it changes it to answer. The original equation will be up top, and that was 3x squared minus 4x minus 5. Parentheses around that, so the order of operations is maintained. Divided by 6x minus 4. Again, 6 answer minus 4. And you can see what's happening is within a few steps, you're seeing exactly where it crosses the x-axis. Okay, there it is. We didn't have a change. So that's going to be it. 2.119632981. I'll write that down on the other page. And that's our answer. And it's as accurately as possible. So, you know, I went out to a whole bunch of places. 9 places to be exact. That's pretty solid. Let's go ahead and cheat and just use the calculator like we're back in Algebra 2 and see what we get. See if we get 2.119. Okay, here we are. Second calc. Number 2 is 0. Left bound. I could stay where I'm at. I'll go a little closer to it. That's cool. Enter. Right bound. Make sure you cross. Okay, cool. Enter. Do you want me to guess? Well, now you know what that means. It's going to use Newton's method. Yeah, sure, do it. Hey, check it out. 2.119633. 2.119633. See, the problem with that answer is if you don't know how to do Newton's method, you're not going to be very accurate. You're only out to 6 places. That's still pretty good. but the answer on my teacher key is out to 9 places. And I'm going to say, oh, you have 633. Can you tell me what the last 3 digits are? And you don't even know if the 3 is right. Actually, it's a 2 rounded up. You don't have a very good chance of faking this. And I'm going to know whether you use Newton's method or whether you just try to cheat and use, the grapher. So it's kind of cool. All right, we're going to do one more and then we will be done. We're going to use Newton's method to find where 2 graphs are crossing each other. We're going to find an intersection point. All right, so we have a cubic and then we have a trig graph. I'm telling you that they're going to intersect in the first quadrant somewhere, and I want the intersection point as accurately as possible. All right. Well, if they intersect, that means they're equal. So I'll go ahead and start by setting them equal to each other. We'll take this and set it equal to 5 sine 2x. In fact, let's get a 0 on one side. I'll subtract 5 sine 2x from both sides, and that'll get a 0 on the right. All right, there we go. And again, in true Isaac Newton form, I'll get rid of the equal 0. We'll call this whole thing y instead. I'll put the y in the beginning this time. And then we take the derivative to get y prime, which will be x squared minus 6. We've got trig and we've got a chain rule. That's going to be minus 10 cos 2x. Derivative of the sine is cosine, and then there's the extra times 2 from the chain rule. All right. Let's put that into the calculator and see what we get. All right, I've typed them both in. Let's see where they intersect each other. You can see they intersect 3 different times, but only once in quadrant 1. And it looks to be somewhere between 4 and 5. So I think I'll make my initial guess 4.5. All right, let's go to the main screen and just do it. 4.5. Enter. And then we subtract the fraction that we've figured out. Original on top, so that's going to be 1/3 x to the third minus 6x minus 2 minus 5 sine 2x. Remember, all the x's are going to be answer instead. I don't like the way I can't see the whole screen. That makes me a little nervous. I did type in the numerator. Divided by, and I'll type the denominator in as well, but you know what? Let me move around here just a little bit. I'm going to go to mode. And up top, it can be changed to classic, which is a nice way of saying old school. Let's do that. Okay, you can see that classic mode enables me to see the entire equation, which I really appreciate in case there's any mistakes in there. I don't have to go searching for them. I started with a 4.5. Notice I went answer minus. I've got all the parentheses. No x's, all answers. And also I'm in radians. Anytime you mix trig and non-trig together, as I'm doing here, you got to be in radians. In fact, you'll be in radians 100% of the time in AP Calculus. So if you're in degrees, you got to switch out. All right, let's see what we have. We'll hit enter. We'll try to hone in on the final answer. And there it is. You can see the decimal has not changed at the end. And so I have 4.529, 042152. Let's see if that agrees with where they cross on the graph. Again, we'll go second calc intersect. The graphing calculator is also using Newton's method, but it won't be as accurate as we are because their screen doesn't go as far out. First curve, second curve. Again, we want to be closer to the first quadrant point, otherwise we'll be sucked over into one of the other answers. So it's important to move it first. Guess, yep. And again, the answer I just got was 4.529. 042152, and you can see that obviously that's what this is, but you can see we're accurate to an extra 4 places right here. Instead of 22 at the end, we have 2152. So again, that's kind of cool. All right, Newton's method. Again, optional topic, but very cool. And the derivatives involved are very simple, but very powerful. Okay, till we meet again, take care, everybody. See you later.